Hello students, in this lecture we see the remaining two examples of the exercise 3.2c. Here the example is evaluate the integral of 3 cos x upon 4 sin x sin square x plus 4 sin x minus 1. Okay, here to find the integral of any function. Okay, here to evaluate the integral there is a one question, it is a problem. Okay, first see the problem, okay, and follow the 3 steps. First step, check the problem in which type. Second step, if the problem is not in our given type, then the second step is check there is a substitution or not. Okay, and if we can't substitution, then follow the third step, that is the simplification. That means we use the trigonometric formula or the algebraic expansion. Okay, here first see the type first see the example in which type, then substitution and then simplification. Okay, here we have already seen the several types of the integrals, that is in the exercise 3.1 we can see the types, that is the if the degree of numerator and denominator is same, then adjust denominator as it is in the numerator. If degree of numerator is greater than degree of denominator, then divide them and then solve the integral. And in the trigonometric function, if there is a sin square, cos square, tan square or sin cube, cos cube, then use the formulae. After that we see the substitution. Okay, and in the substitution method, okay, we substitute the composite function, okay, and reduce it in the standard form and then integrate. And in the substitution method we can see the special types, that is the a sin x plus b cos x upon c sin x plus d cos x, and the solution method is here we can see it is integral of a sin x plus b cos x upon c sin x plus d cos x, and the solution method of that type. Okay, here it is a into, it is a numerator is equal to a into denominator plus b into derivative of denominator. It is our first type. Then we see it is a into e raised to x plus b upon c into e raised to x plus d. Again same method, that is numerator is equal to a into denominator plus b into derivative of denominator. Then integral of our type, it is 1 upon quadratic function ax square plus bx plus c dx. Okay, after that we can see it is integral of 1 upon a sin x plus b cos x plus c carefully, it is 1 upon quadratic function. To solve this integral, we by using completing square method we can reduce it. X square and a square, there are 2 terms, and we use the special integral of 1 upon x square plus a square, 1 upon x square minus a square, and 1 upon a square minus x square. In this method, here 1 upon a sin x plus b cos x plus c. In this method we put tan x by 2 is equal to t, dx is equal to 2 dt upon 1 plus t square, and sin x is equal to 2t upon 1 plus t square, cos x is equal to 1 minus t square upon 1 plus t square. After the substituting all values we get 1 upon quadratic function, and again solve by using this method. Okay, after that we can see the fifth method. Okay, here 1 upon a sin 2x plus b cos 2x plus c. Again same procedure. Here there is a put tan x by 2 is equal to t, here put tan x is equal to t, and the same. And then 6 1 upon a sin square x plus b cos square x and plus c dx. There is a solution method. It is divide numerator and denominator by cos square x. In denominator use sec square x is equal to 1 plus tan square x, and then substitute 1 plus it is sec square x is equal to 1 plus tan square x, and after that put tan x is equal to t. And after substitution again we get the 1 upon quadratic function. Okay, now then next type, it is 1 upon under root quadratic function ax square plus bx plus c. Okay, again same procedure. By completing square method, they reduce 3 terms into 2 terms, that is x square and a square, and we use the special integral of the 1 upon under root quadratic function. then integral of linear function upon quadratic function. Okay, and there is a solution method. Solution method is adjust the derivative of quadratic function in linear function. Okay, the solution method is linear function is equal to a into derivative of quadratic function plus b. We can directly adjust the derivative of quadratic function in linear function. And in the last lecture we see this type, it is a linear function upon under root quadratic function, and process is same. Adjust the derivative of quadratic function, not derivative of denominator. Here we adjust derivative of denominator in numerator, but here we adjust the derivative of quadratic function in numerator. Okay, here these are the several types of the integrals. Okay, here to evaluate any example of the integral, first check the example in which type. Okay, if the example are not in the type, then check is a substitution is there or not. Okay, and if we can't substitute, then the simplification method. But here in this example, this example is not in our type. Okay, see carefully. Then second step, first step substitution, first step it is a type, second step substitution, and third step it is a सिम्प्लिफिकेशन. ओके, इंटिग्रेशनचा कोणताही प्रॉब्लेम जर दिला, कोणताही प्रॉब्लेम असू दे, सगळ्यात आधी पहा कोणत्या टाईपमध्ये आहे. टाईपमध्ये नसला तर सबस्टिट्यूशन करता येते का पहा, आणि सबस्टिट्यूशनही करता येत नसलं तर मग सिम्प्लिफिकेशन. ओके, आता या प्रॉब्लेममध्ये काय तुम्हाला सरळ सरळ सबस्टिट्यूशन करता येते, कारण काय डीएक्सच्या मल्टिप्लिकेशनमध्ये कॉस एक्स आहे अँड पुट साइन एक्स इज इक्वल टू टी. If put sin x is equal to t, then it is cos x is equal to t. After substitution, this example is in our type, that is the 1 upon quadratic function. Okay, here we solve this example. Here to solve any examples of the integral, 3 steps. Remember 3 steps, that is type, then substitution, and then simplification. Now here let I is equal to integral, it is 3 cos x upon 4 sin square x plus 4 sin x minus 1 dx. Here this example is not in our any type, then we check there is a substitution. Yes, it is a cos x is a function which is multiple with dx, and cos x is a derivative of sin x, and sin x is also there. Now here put sin x is equal to t, therefore cos x is equal to dt by dx, that is cos x dx is equal to dt, and then our integral becomes here 3 cos x dx, it is a dt whole to the upon 4 t square plus 4t and minus 1 dt, and now it is in the form of 1 upon quadratic function. Here 3 outside the integral, it is a 1 upon quadratic function, and this integral we can solve by using the completing square method. It is 1 upon quadratic function. Here this problem is not in our type, but after substitution it is in the type. Okay, now here 3 get common, and for the completing square it is a t square, coefficient of t square it is a 4, so we can 4 is also outside, it is a in the numerator 3 and in denominator there is a 4. Therefore integral of 1 upon t square plus t and minus 1 by 4 dt. Okay, now it is a 3 by 4 into integral of 1 upon t square plus t, and then coefficient of t it is a 1, half of 1 it is a 1 by 2, and then square it is plus 1 by 4 minus 1 by 4, and it is minus 1 by 4 already, it is a dt. Now we can write here, therefore our integral is 3 by 4 into 1 upon here t t plus 1 by 2. T plus 1 by 2 square and minus 1 by 4, minus 1 by 4, it is minus 1 by 2, yes, dt. Then it is a 3 by 4 into integral of 1 upon t plus 1 by 2 whole square minus 1 upon under root 2 whole square dt. And then it is a 3 by 4, it is 1 upon x square minus a square 1 by 2a log of x, it is 1 by 2 minus a upon x plus a and plus c. Now here 2 get cancel, there is a 3 upon under root 4 under root 2, it is 4 and it is under root 2, and here log of, here we multiply by 2, then we get 2t plus 1 and minus under root 2. See carefully, here we multiply by 2, numerator and denominator, whole to the upon 2t plus 1 and plus under root 2 plus c. Okay, we multiply by 2, and then last answer put the value of t, 4 under root 2 log of 2 into sin x plus 1 minus under root 2 whole to the upon 2 into sin x plus 1 and plus under root 2 plus c. Okay, here it is the last answer. See carefully this example. Now we can see the next example here. Okay, first read carefully the example, that is the question. This question not in our type, so we take the substitution. Okay, and after substitution it is in our type. Now next example, it is the 9th example. Integral of under root e to the power 3x minus e to the power 2x upon e to the power x plus 1. Okay. Now here the given example, let integral is equal to under root of e to the power 3x minus e to the power 2x whole to the upon e to the power x plus 1 dx. Now this example is not in our any type. Okay, so we can check there is a substitution. Now it is a single term multiplication of dx, it is a complete under root. Okay, so here simplify this, it is a e to the power 3x and it is e to the power 2x, so we can common e to the power 2x. Check the all calculations, see carefully, it is e to the power 2x into e to the power x minus 1 upon e to the power x plus 1 dx. Okay, here only in the numerator we can common, it is e to the power 2x, and here e to the power 2x can take outside the square root. The square root of e to the power 2x, it is a e to the power x. So we can write here, it is e to the power 2x can write outside the integral, outside the square root, it is e to the power x. So we can write here under root of e to the power x minus 1 upon e to the power x plus 1 into e to the power x dx. We can write this e to the power 2x outside the integral. Now in the multiple of dx there are two terms. one is e to the power x and one is under root of e to the power x minus 1 upon e to the power x plus 1. Okay, here now in the multiple of dx there is a e to the power x, and e to the power x is a derivative of e to the power x. So here we can substitute e to the power x is equal to t. Okay, now here put e to the power x is equal to t, therefore we can write e to the power x dx is equal to dt, and now our integral becomes under root of t minus 1 upon t plus 1 dt, and such type examples we can see in the last lecture. Okay, under root of t minus 1 upon under root of t plus 1. Here we multiply numerator and denominator by under root of t minus 1, then we get linear function upon under root quadratic function, and linear function upon under root quadratic function we can solve adjusting the derivative of quadratic function in linear function. Okay, now this example we can see in the last lecture. Therefore our integral becomes, it is multiply numerator and denominator by under root t minus 1, then it is a t minus 1 upon under root t plus 1, multiply numerator and denominator by under root t minus 1 upon under root t minus 1 dt. Now we get here it is t minus 1 upon, see carefully, under root of t square minus 1 dt. Here when we multiply this we get this function, and it is linear function upon under root quadratic function, linear function upon under root quadratic function, and the solution of method of such type, it is adjust the derivative of quadratic function in linear function. Now the derivative of quadratic function, it is a 2t. Okay, here see carefully, after this step we can write it is a 2t. Okay, but here is a t, so we multiply by 1 by 2 and minus 1 as it is upon under root t square minus 1 dt. Okay, here now this can be written as, here separate the denominator upon under root t square minus 1 minus 1 upon under root t square minus 1 dt. Okay, now we can separate the integrals. See carefully this step. Here separate this integral, here 1 by 2 outside the integral, 2t upon under root t square minus 1, it is a 2t upon under root t square minus 1 dt, minus integral of 1 upon under root t square minus 1 dt. Okay, see carefully this. Separate two integral. Now it is f dash of x upon under root f of x. So this integral, it is a 2 into under root of f of x, and minus it is 1 upon under root quadratic function, that is 1 upon under root x square minus a square. Then the integral is log of x, that is a t, plus under root of x square minus a square and plus c. And now here put the value of t. Here 2 to get cancelled, we get here t square, and t, it is e to the power x. So here e to the power 2x minus 1 minus log of e to the power x plus under root of e to the power 2x minus 1 and plus c. Now it is the last answer. Okay, see carefully. Here this function or this integral not in our type, so we simplify this, then substitute, and then in our type. Okay, here to find the integrals of any function, first check type, then substitution, and then simplification. Okay, here there is a no type, we can't substitute, so we simplify this. After simplification, here there is a substitution, and then it is a type of the integral. Okay, see carefully this.